humans live in so many different kinds of environments here on this planet. We have evolved with this atmosphere, with this geology, and certainly with these other organisms. This is all the result of 4 billion years of working together on this planet.
Yet, in a matter of years, some may leave this inheritance forever, choosing a one-way trip to Mars and the blank slate that awaits them.
The conditions on Mars are almost impossible for our minds to imagine.
When you juxtapose the picture of the planet of Mars against Earth, is just stunning.
And today, we no longer wonder if we will be able to land on Mars. The biggest question now is what happens next?
How are people going to be able to meet all of our survival needs? Food, water, and shelter. How are people going to be able to live and thrive on Mars? Unlike on Earth, where we can ship goods around from place to place with ships and trains and fleets of trucks, getting materials from Earth to Mars is much more complicated. Not only is there a limited amount of space, but it takes a lot of money to launch a rocket from Earth to Mars.
What's more, our launch window to Mars only opens for a brief period every 26 months. If we're going to colonize Mars, our basic human survival needs, water, food, and shelter, will need to come from the red planet itself. But how?
There's actually, many reservoirs of water on Mars.
Scientists estimate that the planet might have enough water resources to cover its surface beyond the height of a 4-story building. We would need that water to drink, to grow crops, even for rocket fuel. But the problem is where most of those water reserves are located.
One of the challenges for a human settlement on Mars would be a balance between a kind of livable climatic conditions. It's much warmer near the equator, and the need for water. Most of the water is at the North Pole or the South Pole or underground near the poles. Near the equator in the summer, Mars can reach up to 30 to 60 degrees Fahrenheit. At the North Pole in the winter, you're talking minus 220 degrees Fahrenheit.
At first, the desire for a more hospitable climate will probably win out, especially since our experience on the International Space Station has shown just how skilled we've become at recycling water. While the average American uses some 80 gallons per day on Earth, astronauts on the ISS use just 1. They're able to do this by recycling urine and sweat, and by creating water through a process that combines excess hydrogen with exhaled CO2.
No rinse, body bath. You squirt it, float a ball of water in front of yourself, and so I'd wash my hands up with that, and then grab a towel and dry them off. But when you're done, we just tuck our towel somewhere to let it air dry so that the evaporated water gets back into the space station and we can use that water again. So it works pretty well.
Getting water on Mars will be challenging, but ultimately there's a lot of water on Mars. So we know that it's there, and we just need to figure out how to access it and how to move it to the places where we need it most. Getting food on Mars is going to be much more challenging.
Human settlers on Mars would be able to use the environment for some of their resources, but they wouldn't find plants there. They wouldn't find food there.
To survive on Mars, we'll need to bring our own plants and our own seeds. And with space being at a premium, both on the planet and on the spacecraft that'll take us there, it'll be essential to know in advance which plants will be hardy enough to survive Mars conditions and which will be able to deliver the calories our colonists will need. There are a few basic problems with growing crops on Mars, starting with the sunshine, water, and soil that plants are used to here on Earth.
The conditions on Mars are more challenging for plants. Sunlight is dimmer. The water on Mars is frozen. And the nutrients on Mars are there, but the soil is toxic.
To address this issue, scientists are now developing greenhouses that'll operate with recycled water and artificial lights. But the plants will ultimately need to grow in specially treated Martian dirt.
On Mars, there's dirt everywhere. We call it regolith, and it's broken up fragments of rock.
It's important to understand when we're thinking about growth on Mars to recognize that rock is not the same thing as soil. There is a vast community of organisms that are in your average handful of soil that really make it a hospitable place for plants to grow.
We'd need to bring our own seeds and bring our own technology for growing those seeds in Mars dirt, probably supplemented with nutrients from Earth.
So what I've done here is we've got some simulated Martian regolith, which actually is essentially ground up rock from the Mojave Desert in the southwestern United States. I've set up an experiment where I've got some wheatgrass that I've grown in the simulated Martian regolith, and then I've also grown some wheatgrass in actual potting soil. And so these wheatgrass crops here have been growing for about 2 weeks under otherwise identical conditions. So what we've done here is really just a small mini version of the types of experiments that are being done around the country and around the world to try to understand how plants will actually grow in real Martian soil. What we can't do is simulate the low gravity or the intense radiation or the toxic perchlorates in the soil. What we can see from the results of our small experiment here is that the plants do grow in the Martian regolith, but they don't grow quite as well as they do in the garden soil. So it's really important that these differences be understood because we have to be precise in our ability to grow plants on Mars. The ability to grow enough food on Mars will literally be the difference between life and death for people living on Mars.
And our experience growing plants on the International Space Station has taught us that our human emotional connection to growing plants can't be overlooked either.
It's a kind of a dynamic event that you can engage in regularly, and there is a contribution to psychological well-being with that. They also grow emotionally attached to it. It's a living thing that they're responsible for, and to see it be successful brings them great joy. But we do have to help the crew plan properly, so when there is something like a plant, a crop doesn't work, that it's also not catastrophic from their health and well-being.
Little by little, scientists are piecing together what a Martian buffet will look like. Plenty of dandelion, radishes, sweet potatoes, kale, tomatoes, and perhaps even hops. But there are a lot of things that won't be coming to a plate on Mars anytime soon, like carrots, corn, most fruit trees, and meat. Not only does traditional livestock require far too much land and water resources, the few attempts astronauts have made in rearing chicks in space have not been promising. In short, there may be beer on Mars, but no buffalo wings or loaded nachos. There may be, however, another tasty, sustainable, calorie-dense, protein-packed alternative for future Martians.
So one alternative to bringing cows and pigs is to bring insects. We can grow crickets on just a small amount of water and food, a fraction of what would be used to keep chickens or pigs or cows. I really like the taste of crickets. It has kind of a nutty, earthy kind of flavor to it. The texture is nice. It's crunchy. It's got a light kind of saltiness to it. you can also grind the crickets up and make a flour. So this flour can be used as a substitute for wheat flour. So you can bake bread out of it, you can make cookies, you can make other types of baked goods. You could even turn it into tortilla chips.
Cheesy nachos may be a no, but cricket chips and salsa are a definite maybe. Science may also bring the Mars community another new protein alternative, one literally pulled out of thin Martian air. The concept was first conceived by NASA decades ago and is now being brought to market by companies in the US and Europe.
Here at Solar Foods, we are producing a natural protein by a fermentation process, much similar to producing beer or wine, for example.
Inside a futuristic-looking bioreactor, microbes are fed hydrogen and carbon dioxide, a resource that makes up 95% of Mars' atmosphere.
Our production process provides very safe and consistent way for protein production.
As the microbes grow and multiply, they produce an edible substance that is roughly 50% protein. When dried, it forms a protein powder that can be shaped, cooked, and presented as a meatball, a burger, or mixed with other ingredients and baked into a crusty baguette. With Martian water to drink and Martian meals to eat, settlers will next need a safe place to live and make the planet habitable for the long haul. Initially, they'll live in habitats brought with them from Earth or sent in advance.
We're going to have to pre-deploy the resources to enable the people to settle it.
Building a permanent settlement from scratch will add a whole other level of complexity.
To build homes or habitats on Mars, you need to think about it, approach it in a very different way than we build homes on Earth. The atmospheric pressure is significantly less than the atmospheric pressure at the top of Mount Everest. And so your home needs to have a complete seal around it so you're not losing air to the broader environment.
And there are the 100-degree temperature swings that can happen within a single day. Massive dust storms that can go on for months, and the unrelenting radiation.
Well, when I think about where I might want to live on Mars, there's nothing quite like the protection of, maybe a meter of rock that would really make me feel safe. We know that the solar particles that are hitting the surface are probably only penetrating a couple of centimeters, and the galactic cosmic rays that are interacting with the surface of Mars are probably only going down about 10 centimeters. So certainly, cave structures or anything underground would offer you a lot of protection from radiation.
There are potential downsides to living in a distant cave or an underground lava tube like you find on Mars.
On the world. Come on in. And there's a beautiful Earth.
Even astronauts aboard the International Space Station, just 220 miles from Earth, struggle with being disconnected from their home planet.
We had to design a window dedicated toward the view of the Earth called the cupola. The crew really rely on that connection.
We've got to find ways to balance between essentially living in a cave and a place like a home we have here on Earth.
Fortunately, the solution to this problem may already be on Mars. Fine grains of Martian regolith.
Actually, I have an example here. This is just the finest component of that Mars regolith. And if we took that finest component and mix it with water and maybe some plant binders, we can actually 3D print this kind of material to make houses or structures for settlements on Mars.
In 2015, with this idea in mind, NASA launched the inaugural 3D Printed Habitat Challenge, inviting teams to design homes that could be built on site on Mars using simulated Martian regolith. For the eventual winning design, Marcia from the AI Space Factory. The first challenge was to address the unique physical and psychological challenge the red planet presents.
We just stepped from Earth to Mars, so we are expecting our needs to be answered. So all of the functionality inside of that building, from the work environment, from to the kitchen, from where you're hanging out with them, because it's going to be a long time, but you're living in just one building.
For the team, the answer is a 4-level structure, 3D printed on Mars. There would be windows on each level, creating a combined 360-degree view. And segregated spaces for work, socializing, and personal space. But designing this structure was just the start.
You're the guy?
I'm the guy.
Started? All right. We're started.
To collect their prize, the AI Space Factory team would need to 3D print a 1/3 scale version of the structure.
Release. Okay, clear.
So we were asked to complete our construction in 30 hours, in 3 days. And it was 1/3 of the scale, but also you felt like I'm walking on a 1/3 of the scale Mars, right?
This line represents roughly where the second floor starts. So if you had a person, they'd be about that tall.
And that was like a dream come true.
Then, watch it endure a grueling stress test.
Like one of the other things that we were really excited about was the moment that the caterpillar machine was trying to crush our structure. And it was so hard for it to crush that the cat started lifting up from the ground as it was trying to crush the structure. And we were like, that's impossible, but that is the material, that is the structure that we have printed.
First place goes to Team AI Space Factory. So.
But once again, the idea of 3D printing habitats on Mars presents its own trade-off.
Mars is smaller than Earth, but if you took all of the land on Earth and squished it together, it's actually about the same amount of land we have on Mars. Depending on where we land on Mars, there will be different ratios of rock and dirt and dust, just like on Earth. And so, the ideal regolith for building may or may not be present in exactly the location we land, especially if we're looking for other resources like water or caves or lava tubes that might protect astronauts from radiation.
Whether future settlers plan on bringing their homes to Mars or building them on site, they're going to have to make compromises. A third model that scientists at NASA and elsewhere have begun exploring presents an entirely new approach to this problem. What if we could grow our own habitats on Mars?
These blocks, they look kind of alien, kind of strange. They're hard. They're really strong. But this isn't some kind of new space-age material. This is actually fungus. So what we've done here is we've put the fungal spores into a preformed block of sawdust. It could be any type of organic matter, actually, including organic waste, like food waste. But once the fungi start to grow, these fungal strands that are linear form a network together of mycelium, and they take on the shape of the block. If we were to let these continue to grow, they would turn into the much more familiar shape of a mushroom. The mushroom is the reproductive structure, but at the base of this entire structure are the mycelium that form the block now of fungus.
Scientists and designers alike are discovering that these mycelium bricks may have some one-of-a-kind build qualities that would be useful on Mars. Not only are they strong and insulating, they can be shaped into almost any form.
One of the things that's so exciting about the possibility of using fungi as a building material is that it forms this really strong, resistant structure. And that's because inside of this brick is a dense network of fungal mycelium. On the inside here is all these little white structures. That white is all of the fungal tissue. All we have to do is grow them in a preformed shape like this, and they'll take on the shape of whatever we want them to be.
At NASA's Ames Research Center, scientists envision homes formed with mycelium, then covered in ice to protect the interior from radiation. They'll also need to protect the Martian landscape from potential earthly contamination.
One of the things we'll need to be really cautious about as we move to Mars is to not contaminate the Martian ecosystems with microorganisms like fungi from Earth. So what we can do is we can actually grow the fungi and then bake them so that we essentially kill or inactivate the live fungal tissue.
So how will we live on Mars? Are we destined to live isolated in our 3D printed homes, living off air burgers, crickets, and leafy greens? Beyond taking care of our survival needs, will we be able to manage our other human emotional needs?
For the first settlers, the idea of return not being part of your mission is such a psychological shift that will have to be dealt with.
How we live, eat, and drink will determine whether or not we can survive on planet Mars. It will also help determine how we adjust psychologically to this extraordinary mission.
It's not only just about getting the calories you need, but actually enjoying it and using it as a way to come together as a small group and celebrate things and have traditions and have ways to mark time are incredibly important.
People living in a colony on Mars are going to have a sense of identity and pride, a lot like what people living in extreme places here on Earth experience.
Martian feasts, Martian architecture, Martian celebrations, and Martian sunsets. Every day we spend on Mars will move us one step further from our home on Earth, and one step closer to becoming true Martians. But as our approach to surviving on another planet evolves, inside of us, down to our DNA, we will continue to evolve as well, in ways scientists still don't completely understand.